Hi everyone, in this video we are going to be talking about limits. I'm going to give an introduction of limits and help you figure out a little bit about what they are and how we calculate them. So in order to motivate this, I have this table of x and y values right here. So this first row are the x values and then the second row is the y values. And I want you to look at this table and we're trying to think about what's happening around x equals 7. So if you look at this table, I don't actually have a value for x equals 7 listed here, but I have some values that are really, really close. So I have 6.9, 6.99, 6.999, so we're getting pretty close to 7. And then likewise, if I approach from the right, I have 7.01, 7.001. So those x values are getting pretty close to 7. And I want to know what's happening to the y values as x gets close to 7. Well, if we look down here at this row, we have 3.5, and then we move to 3.9, then we move to 3.99. And if we come from the other direction, we start at 4.1, and then we move to 4.01. So you might see a little pattern here. You might see that these y values are getting kind of close to some number. So I want you to see if you can guess right at x equals 7, what do you think the y value should be based off of this table? And so to kind of get a better idea of what's happening here, we can draw a picture. So what I'm going to do is I'm going to take these x and y values and I'm going to plot them on this graph. So we know that it's 6.9. When x is 6.9, our y is 3.5. So that's going to be about right there. And then we know that at 6.99, y is 3.9. So that's going to be somewhere right there. And then at 6.999, y is 3.99. So we're going to be somewhere about there. And then once we're a little past 7 at 7.001, we have 4.01. So maybe that's right there. And then at 7.01, we're at 4.1. So this is a rough sketch of our x and y values. And so if we connect these with a line, maybe it looks something like this. Okay, and my original question was, when x is equal to 7, what is happening with y? What is y equal to? Well, so right here is around x equals 7, this red line. And what do we think is happening with y? Well, let's draw a little line out to the y-axis. So it looks like that at x equals 7, our y value looks like it's 4. And so maybe that's what you guessed from this table, right? Because right around x equals 7, right in that spot, our y values were really, really close to 4, right? So we can kind of guess, we can kind of expect that right at x equals 7, our y value is going to be 4. So what did we just do? Why did we go over all of that? Well, believe it or not, you just calculated a limit. So what do I mean by that? So let's call this function right here f of x. What we just did is we figured out that the limit as x approaches 7 of f of x is equal to 4. So what are limits? Limits are when you're given some x value, the problem tells you an x value, in this case it was 7, and the problem asks, what do the y values of the function get really, really close to as your x value gets close to 7. And how did we figure it out? Well, we drew a little picture of our graph and then we traced our graph from the left and we're like, okay, as we're getting close to an x value of 7, it looks like our y values are coming to 4. Same thing from the right, if we trace this graph, as our x values are getting really close to 7, it looks like our y values are really getting really close to the value 4. So that's what a limit is. It's asking you, okay, if I give you an x value, can you tell me what the y values of the function are doing? Can you tell me what the y values get really, really close to? So that's the idea behind a limit. It's all about, okay, I give you an x value, what are the y values doing? And so this is the notation. So this is the limit we just solved for. And I just want to talk about the notation. So this part right here, lim, that means limit. And then this part right here, the x, tells you which x value we're interested in. So this right here is saying, hey, the x value I want you to investigate at is x equals 7. And then this part right here tells you which function we're looking at. So if you have multiple functions on a graph, this is saying, hey, I want you to find the limit of the function f of x. And then on the right side here, this is what we solve for. This is the y value that the function gets really, really close to as x approaches 7. And so how you would pronounce this whole thing, if you were to say it, is you would say the limit as x approaches 7 of f of x equals 4. So let's do another example. Oh, and then also one thing I wanted to point out, because this is something that students can kind of get confused sometimes, is that when you're finding a limit, the answer is always going to be a y value, not an x value. So, right, we figured out that the limit was equal to 4. 4 was the y value. So make sure that you remember that when you're finding what the limit is equal to, it's always going to be equal to some y value, not an x value, at least for AP Calc. Okay, so now we're going to move on to this example. And so here you can see I've used that same limit notation again. And this is saying, what is the limit as x approaches 3 of the function x squared? So this time I didn't give you a picture, I gave you what the function is. But this function x squared is a parabola, and we know what that looks like, so we can go ahead and draw our own picture. So parabolas, they look like a U, so maybe it looks something like that. Okay, and then this notation is telling us that we want to find the limit when x is 3. So that's our point of interest. The x value we're interested in is 3. So let's go ahead and plot that point on this function. So let's say 3 is right there. When x is 3, what is the y value equal to? Well, we know that our function is x squared. So if we plug in 3, 3 squared is 9. So I know that the point that we're interested in right here, that is 9. So I'm going to label that point 3, 9. Okay, and so now let's think. They're asking us to find the limit. What does it mean to find the limit? Well, they want to know, as the x values get really, really close to 3, what do the y values get close to? So if I take my function and I start, oops, that's not what I want to do. If I take my function and I start tracing it from the left, as x gets really close to 3, it looks like my y values are getting close to 9. And then same thing from the right. As we get really close to an x value of 3, it looks like my y values are getting really close to 9. So that is the answer to this limit problem. As x approaches 3, the limit of x squared is equal to 9. So now you might be wondering, to find a limit, do we just plug the given x value into our function? Because I mean, you could, that kind of seems like what I did up here, right? Our given x value is 3. If you plug 3 into the function x squared, you get 9. And that was the answer to our limit. So it kind of looks like, well, in order to calculate a limit, we just plug the x value they give us into the function, and that's our answer. And that's a reasonable thing to think, but there can be some situations where that doesn't quite work. So let me show you one of those situations. So right here is the graph of some function f of x, and they're telling us that they want us to calculate the limit as x approaches 2 of f of x. Okay, but what's weird about this function? Right at x equals 2, we have a hole. So that's a little hole in the graph, which means that the graph doesn't have a value there. It's undefined right at that point. So they're asking us to find a limit at a point where the function doesn't exist, right? The function isn't defined there. So that seems kind of weird. And you might think, well, there's no answer then, right? How could we do that if the function isn't defined there? But this is where we need to remember that a limit is not asking you to just calculate what the function value is there. They are not asking us, hey, when x is 2, what is y equal to? Instead, they're asking us, as x gets really, really close to 2, what does y get really, really close to? And I know that might seem like kind of a dumb, not really a difference, but there is a subtle difference between those two things. So asking you to calculate what the function value is equal to is not the same as asking you to find, as x gets really, really close to 2, what does y get really, really close to? So this limit actually does have an answer. Let's figure that out. Okay, so they're asking when x gets close to 2, what does y get close to? Well, if I start right here and I trace my function, as I'm getting close to an x value of 2, it looks like y is getting close to 10, right? Because it looks like that spot is around a y value of 10. And then same thing, if I trace my function from the right, as x approaches 2, it looks like y is getting also really, really close to 10. So actually, the answer to this problem is 10. Our limit is equal to 10. And that's because a limit just asks you, as x gets really, really close to some value, what do the y values get really, really close to? The y values don't actually have to reach 10. The y values don't actually have to become 10. They just have to get really, really close to them. So that's why in this case, our limit is 10. So hopefully that was helpful to you. In the next videos, we are going to talk about some more limit properties. We're going to introduce left and right hand limits, and we're going to go over some trickier examples. So make sure you check those videos out. And if there's anything else you want to see or you have any questions, make sure to comment. Thanks.